Hello, in this video, part 2 of our discrete distributions, we're going to cover the geometric distribution. So what is this new distribution? The geometric distribution describes the probability of running a certain number of trials, Bernoulli trials, over and over again, and we want to know what's the probability of running those trials and not getting a success until the X trial, or any number of trials. So let's look at an example. Suppose I'm rolling a dice, and the number of times I roll a dice, I want to know how many times I have to roll the dice until I get a 6. So let's call the number, number of times you have to roll the dice until you get a 6. Yeah, so let's call this number X. And so we're going to find the probability of X equals 1. That means rolling a dice one time and getting a 6. So basically, what's the probability of getting a 6 on my first try? I would say 1 out of 6. Okay, that's not so complicated. Now what is the probability of having to roll the dice twice before I get a 6? So if I have to roll a dice twice, that means that for the first time I get not a 6. So probability of not 6 would be 5 out of 6. And I'm going to multiply that times probability of getting a 6. Because I did get a 6 on the second try. And they're independent events, so 5, 6 times 1 out of 6. So I'm going to copy paste that for my next one, because I'm doing the same thing, but I'm rolling my dice 3 times. So the probability of not getting a 6 twice would be 5, 6 times 5, 6. So I could say 5, 6 squared. And then I do get a 6 on the third try. So X equals 3 would be the third try. So you see the pattern. I think you can finish that problem. And then based on this pattern, we want to know, what's the pattern here? What's the formula? And so I'm going to write this not as an equation, because I just want to make it a formula. The pattern is I roll the dice n times and get a 6 for the first time on the nth try. That means I get n minus 1 failures, and then 1 success. So if 5 out of 6 is a failure, not getting a 6, I would say 5 out of 6 to the n minus 1. So that's the n minus 1 failures, is that part. And then 1 success, 1 out of 6. So that formula would describe any value for this distribution, any value. And the general formula, if P is the probability of success, then 1 minus P would be the probability of failure. So we could write it like this: 1 minus P to the n minus 1 times P. So here's the geometric distribution for flipping a coin. So flipping a coin would look like this. Most likely is to get a 1/2 to get a heads on the first try, 1/4 to get a heads on the second try, 1/8. So it has that nice curve. But I could make this formula, I could modify this and do the situation we just did, 1 out of 6. If that's my probability of success, I could say rolling a 6, see if that looks any different. Notice it's a little flatter. Probability of rolling a 6. They don't change as much. So these are examples of geometric distributions. So I'm going to copy that. I think we're going to use that. And let's look at this. Insurance example. If we're calling P the probability of a success, and success is meeting one's deductible, well, P is then 30% written as a decimal. So let's modify this code. Let's do the same distribution, but our probability of success is 30%. And let's change our title to correspond to meeting one's deductible. Boom. And there's what that distribution looks like. So we see for each outcome, having the first person meet the deductible, the second, the third, we have a different probability of that event occurring. And notice, as long as my probability of success is greater than 0, I will always have the potential to have infinitely many failures before I have a success. So that's why it looks like this. It has it's called an asymptote if I were to draw this continuously. So I think you can answer these next ones on your own, but if you want to use a formula, this little bit of code here, 1 minus p times to the n minus 1 times p. Well, that's the formula for a geometric distribution, and we could use that. I just want to make sure I have the probability of success correctly. And instead of 1 to 10, this lists 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just want to know what's the probability of getting success on the 4th one. And since I just want to look at the output of this, I could just run that bit of code and see, hey, I'm taking, really what this does is I say 0.7, this makes more sense to you, to the third power, 3 failures times 1 success, 0.3. So if that makes more sense to you, you can do it either way. I think you can do that one. You can do 10, same thing, but it's a geometric distribution where it looks like your probability of success will be guessing. If you're guessing on a 4 multiple choice quiz, it'll be 4. N will change, and you just can use the same formula. Up until part D. If you get to D, that means you're just getting 4 failures in a row. Not D, excuse me, I'm thinking of E. If you get 4 failures in a row, what's the chance of that? So if I call failure a given probability, I would just say the probability of failure to the 4th. So whatever the probability of failure is in this case, it's just 4? Yeah, 4 multiple choice questions. Anyhow, I went fast. Pause this. Please work on this rest of this question. And when you come back, I will talk about the binomial distribution. So, but I'll put that in another video so you can find it easily. All right, have fun. See you there.